Hi, so happy you joined me today. I'm going to talk about phase diagrams, or as one person in his training taught me. I think it was Todd Abramowitz, taught me. He calls them the butt diagram, and I think you'll see why in a minute. Now, in previous videos, I have talked about changing the temperature in order to cause a phase change: solid liquid, solid gas, and so forth. Well, it's also possible to change phases by altering the pressure. So I'm going to show you what it would look like, pressure and temperature. We're going to identify some key points and transitions on this curve. So I've got a curve, it's a cheek and a curve, another cheek and a line. I think you get the idea. And out comes the gas. So we have gas in this line segment. We have solid here and liquid here. Okay? Now, if you were talking about points on the line, those are your phase transitions. Okay? So every point on here is going from liquid to gas, which would be vaporization, or gas to liquid, which would be condensation. Every line here, every point on this line is called a phase equilibrium. Solid, going to that, is melting. Liquid going to solid is freezing. Okay, solid going to gas directly is sublimation. Gas going directly to solid is called deposition. Okay? Now, if we are at, I'm going to erase this so that I can show you some more points on this. If I am at 1 atmosphere, so let's recreate this very quickly. I've got pressure, temperature, curve, curve, line. Okay, remember that was solid, liquid, gas. If we are at 1 atmosphere of pressure, we use the word normal in front of the melting in that case and the boiling in that case. So this would be called my normal boiling point, and this would be called my normal freezing point. All along the line are freezing points. We just use the word normal in front if it's at 1 atmosphere. Okay? Now, some other points you need to know is this one. At this point, so let's first look at these other lines, and I think that point will make a little bit more sense. If you are on that line, you have both solid and liquid. During a phase transition, you have both phases present at the same time. On that line, I have both liquid and gas present. On this line, I have both solid and gas. So during the phase transition. So hopefully it's reasonable that at this point, I have solid where they intersect: solid, liquid, and gas. And that's called the triple point. Okay? Now, it's an equilibrium. It's hard to achieve. There's some good videos online, especially if you look at some videos with tertiary butyl alcohol. You can see those. I want to extend this a little bit out. Okay. There is also another point up here. Okay. And if you look at that, if I drop that down, if I could draw a straight line, if I drop that down to the temperature, that's called the critical temperature. Okay? And in this region of space, here, it's like you could draw a line up there. You cannot liquefy the substance regardless of the temperature you choose. So this will always be either a gas, or sometimes there's a range called a supercritical fluid that you might talk about in physics. But the point is, if you are above this temperature, everything above this temperature, you cannot liquefy it. So no liquefying. Even if you raise the pressure tremendously, we can't liquefy it. Now, the pressure at that point is often referred to as the critical pressure. But it's really the temperature that's the critical part, and then the pressure is the matching pressure. So those are some of the conceptual things you would need to know about a phase diagram. If you happen to be one of my students, we're not going to do mathematics with this, but you are going to have to identify phase changes as we change pressures and temperatures. And so that would be application of this that we would do in class. So I hope this helps you in your class, and thanks for joining me in your learning journey. Take care.